Hello children, today we are going to learn about electric dipole. From the word dipole, what do you understand? Di means two, right? So it will be two equal and opposite charges separated by a short distance. Two equal and opposite charges separated by a short distance will constitute an electric dipole. The schematic representation is as shown in the figure. You can see here there are two equal and opposite charges separated by a small distance. The distance between the dipole is taken as 2a because from the center, this will be a, this will be a. The total distance of separation, how small it is, it will be taken as 2a. Okay, so two equal and opposite charges separated by a small distance is called a dipole. So when does this dipole occur, or what is dipole moment? We will discuss about dipole moment now. Okay. So when there is a separation of charge, dipole moment will occur when there is a separation of charge. Okay. So separation of charge, we have to write. 1 minute. Okay. Yeah. Separation of charge. So they occur between two ions in an ionic bond. You all know about ionic bond and covalent bond. So they occur between two ions in an ionic bond or between two atoms in a covalent bond. Covalent bond is due to sharing and ionic bond is due to losing or gaining. Okay. So it is between, ionic bond is formed between ions. So that is why we say they occur between two ions or two atoms based on the bonding. The factors that influence the dipole moment are factors that influence will be difference in electronegativity. You know what is electronegativity, right? You would have studied in chemistry. Electronegativity is the tendency of an atom to gain electrons, to acquire electrons. Okay. And the distance between the charge separation. Distance between the charges. So dipole moment is usually measured in d by units. D by units, which is DE/BYE, D by units. And 1 D by unit is equal to 3.34 into 10 to the power minus 30 Coulomb meter. Okay. This is 10 to the power minus 30 Coulomb meter. Examples of dipole moment possessing molecules will be water molecule, hydrochloric acid molecule. And what is the use of this dipole moment? This dipole moment is usually to increase the stability of the substance. The stability of the substance increases when there is a force of attraction. The negative end will attract the positive end when they are separated by a distance, and so the stability of the substance will increase. Okay. So this is what you would have studied in detail about dipole moment in chemistry. So we are not elaborating too much. Dipole moment is occurring due to the separation between the charges, and The factors that will determine how strong the dipole moment will be occurring is the difference in electronegativity between the two charges and also the distance between the charge separation. SI unit is D by units or Coulomb meter. Okay, that is what mentioned here. It is and how to calculate the dipole moment. It is the product of one of the charges multiplied by the distance between the two charges. That is, we said that for a charge plus and minus, the distance is 2a. Okay, so the distance is 2a and one of the product of the magnitude of one of the charges. Okay, that is dipole moment is represented by P vector because they have a direction. Okay, what will be the direction of a dipole? The direction of the dipole is from negative to positive. Negative to positive. The direction of dipole will be from negative towards positive. Okay. So that is the reason dipole moment is a vector. So, and it is calculated by the product of one of the charges and the distance between the two charges. Unit of electric dipole moment is Coulomb meter. We have already saw another unit which is called D by units. And one D by unit conversion to Coulomb also we saw. That is 3.34 into 10 to the power minus 30 Coulomb meter. Okay. So, and finally that dipole moment is a vector quantity and its direction is from minus Q to plus Q. That is, it starts from the negative and ends in the positive. Okay. This is all about electric dipole and dipole moment. So now the field produced by an electric dipole is called a dipole field. You can see this diagram. Two equal and opposite charges separated by a distance. So take this plus Q and this minus Q. So now you can see that there is a field produced that is called a dipole field. When we bring these two charges, what happens is they cancel each other and the net charge will be 0. Charges follow additive. Charges are additive in nature as we saw in the first class, right? So where the plus charge and minus charge get cancelled out and it becomes 0. So the total charge will be 0. But the field, as it is separated by a small distance, the field cannot be 0. Okay. So there will be a field pattern existing. So the total electric field of a dipole is not 0. Whereas the total charge of a dipole will be 0. So the total field is not 0, whereas the total charge is 0. Okay. So with this understanding, we will do two numericals. One is two charges plus 5 microcoulomb and another minus 5 microcoulomb are placed 1 millimeter apart. 1 millimeter means it is equal to 10 power minus 3 meter. You have to calculate the dipole moment. So P vector is equal to Q into 2A. So our 2A is 10 power minus 3 meter and our Q is 5 microcoulomb. Micro means 10 power minus 6. Okay. So 5 microcoulomb is 5 into 10 power minus 6 coulomb. So 5 into 10 power minus 6 into 10 power minus 3. So you will get it as 5 into 10 power minus 6 plus minus 3. So it will become 5 into 10 to the power minus 9 Coulomb per meter. Okay, please don't forget the unit. SI unit is very important. Coming to the next question. Two charges. A system has two charges QA and QB is given. Located at point 0, 0 minus 15 centimeter and plus 15 centimeter. So, you know the first value when it is a 3D picture, first value is X, Y, Z. So now in the Z axis, you can see that one side is taken as plus 15, another side is taken as minus 15. What are the total charge and electric dipole moment of the system? What will be the charge of the system? You know that dipole means two equal and opposite charges separated by a small distance. So, one charge is positive, another charge is negative. So, when they are added up, total charge will become equal to 0. Because plus 2.5 into 10 power minus 7 coulomb and minus 2.5. Sorry, and see, charges are additive in nature, right? So, plus into minus you have to write. Minus 2.5 into 10 power minus 7 coulomb will be equal to plus into minus is minus, right? So they will get cancelled and you will get 0 as the answer for the total charge. But there will be a dipole moment, right? Because there is a distance of separation between them. Now how to calculate the distance of separation between them? We know that we are going, electric dipole moment, we are going to calculate Q into 2A, right? So here, the distance between the origin and the point A is 15 centimeter. This side it is 15 centimeters. So 2A will be equal to 2 into 15 centimeter, right? So it is 30 centimeter. So what is 30 centimeter in meter? That is 30 by 100 will be equal to 0.3 meter. Okay. So now you have to substitute this value 0.3 into the charge value 2.5 into 10 power minus 7. Okay, so you will get this as the answer 0.3 into 2.5 into 10 to the power minus 7. So 0.3 into 2.5 is 7.5 into 2.5 into 0.3 is 0.75 into 10 to the power minus 7 Coulomb meter. Now to make it like in scientific notation, it is 7.5 into 10 to the power minus 8 Coulomb meter. So I hope you have understood this concept. What is electric dipole and what is the dipole moment possessed by a dipole. Okay, and finally the importance of the dipole moment, it is to increase the stability of the substance. Okay, so with this we are closing this class. I hope you have understood. If you have any doubts, please message me in the comment section. I'll be happy to help you. Thank you.